Hello, my dear students. Welcome to my presentation again, Math 30-1, Pre-Calculus 12. Today, I am going to continue the lesson of polynomial function. Polynomial function video number 3. In my previous two videos, I have discussed question numbers from 1 to 12. Today I am going to start from question number 13. Question number 13 says, use the following information to answer to next two questions. What is that? A rectangular prism has dimensions x centimeter, 9 minus 6, 11 minus 6. Determine the maximum volume of the prism to the nearest tenth of a cubic centimeter. Okay, dimensions have been given in a rectangular prism. X centimeter, 9 minus 6 centimeter and 11 minus 6 centimeter. We have to find the maximum volume. Okay, let's use this formula to find the volume. V equal L times W times H. This is a formula to use to find the volume of the right rectangular prism. Length, width, height. Length time, width time, height. You can consider any dimension as length, width, height. Okay. Now, volume is equal to x multiplied by 9 minus x multiplied by 11 minus 6. Now, we can rearrange this equation so that coefficient of x appears as positive. That means instead of 9 minus 6, I can change the sign minus x minus 9. Here also I can reverse the sign as minus x minus 11. Then minus times minus will become positive. Then this will become, overall v is become h times x minus 9, x minus 11. Okay, actually this is a polynomial function. This is a polynomial function. What's the degree of the polynomial function? The degree of the polynomial function, when you expand, you understand the highest power of the polynomial function is s cube. That is one thing. Coefficient of highest power is 1. This is a odd power function, actually cubic function. Leading coefficient is positive. If the leading coefficient is positive, power of the function is third order power, then we know shape of the function. This is usually look like that, shape of the function. That means this function is parallel to y equal x. That is one property. This is the shape of the odd power function with leading coefficient positive. Function has the shape of y equal x. Function has orientation of y equal x. Other two properties are in the third quadrant. In the third quadrant, function extends to the third quadrant in up direction. Also, function extends to the first quadrant in up direction. Like that, okay? Here actually moving down, usually like this. In the third quadrant, function open, extend to the third quadrant, down. Here extend to the first quadrant in up direction. Okay, actually here you have to plot this graph. You can plot this graph in the graphing calculator. If you plot this graph in the graphing calculator, how your graph look like? This is origin, x-axis, y-axis. Let's consider x-intercept. When you make v equal to 0, when you make y equal to 0, you are getting x-intercept by 0 by setting this 0, you are getting SC equal 9. From this, you are getting SC equal 11. By setting this each product to 0, you are getting the x-intercepts as 0, 9 and 11. You can indicate those x-intercepts here, 0, 9, 11. That is one thing. Then you can draw the graph like this. This is partial graph. This side also, if you develop, this is the way. Okay, you must plot this in your graphing calculator using the technology. Then you are getting a graph of this kind. What the question says, determine the maximum volume. Determine the maximum volume of the prism to the nearest, nearest cubic centimeter. You know, this is the maximum value, no? The y coordinate is maximum at this point, minimum at this point. Okay? But here actually we have to consider some practical situation. In the real situation, the dimensions cannot be negative, no? We are considering a rectangular prism like this. These are rectangular prisms. These are the dimensions. X, 9 minus 6, 11 minus 6. We are finding volume. Volume can never be negative. Dimensions also can never be negative. That means after ignoring those restrictions, we can cut this part of the graph. Now we have to be mind around this. There is no graph around this here also, okay? We have to consider only the graph located in the press quadrant. Okay, however, we have to read this S coordinate. If we use a graphing calculator, from the graphing calculator, you are able to observe this S coordinate as approximately 3.283, as I remember like this, 280. Then you have to figure out this Y coordinate. If you figure out this Y coordinate, out of this option, what are they? Actually, I am not sure this nature also. Sometimes this may go like this also, maximum, minimum, okay? That doesn't matter. We have to follow this shape. I draw this shape only. This negative value, I am not sure about this, okay? Okay. C is 36. I think out of these values, when I check the value, this is the right answer. Right answer is A. A is the right answer. Okay, let's move to next part of the question. Question number 14. We can discuss the question number 14 also at the same time. Use the information from the previous question to answer this question. This question asks, what is a suitable domain for X? What is a suitable domain for X? Okay, in order to understand that, in order to understand the situation, let's mark these dimensions in a number line. 0 is here, 9 is here, 11 is here. Now all these dimensions should be positive. X has to be positive mean we can mark the interval for X like this. This is for X. 9 minus 6 has to be positive. S has to be positive like this. We already applied this result, okay? We already interpreted this one in the number line. Other one is 9 minus x also has to be positive. What do you get from here? When you solve this inequality, if you add plus x to both sides, 9 greater than x, that means when you reverse this inequality, s less than 9. Now let's interpret this one. S less than 9 means this should be like this. This is s greater than 0. This is for the second inequality, 9 minus 6 greater than 0. Other one is in the same way, we can understand that 11 minus 6 greater than 0 means it's less than 11. I wrote this directly. Okay. That means in order to satisfy all these three conditions, we have to address this common region, the common interval. Okay. If you consider this interval, the domain, that means x values within this interval satisfy all these three conditions at the same time. That means the suitable domain is between 0 and 9. Suitable domain for s is between 0 and 9. That is, answer is D. Answer is D. Okay, dear students, now let's look at the next question. Question number 15. Question number 15. Question number 15 asks, based on the graph of fx, fx has been given. Based on the graph of fx, what is the real roots of this equation? They have given the equation. I am not writing here, okay. Question asks, the roots of fx equals 0. The root of fx equals 0 means the graph has been given. The graph is like that. From the graph, we can understand this s-intercept. 4, 2, -2, -6. They are given the graph. This should be a quadratic function, fourth order power function with positive coefficient. Directly we can read the x-intercept. Really, roots are the x-intercept, no? The roots of the polynomial equation is x-intercept. These are the roots clearly. 2, 4, -2, -6. -6, -2, 2 and 4. These are the roots. These four values are included in option number D. Option number D. -6, 4, 2, -2. Yes, answer is option number D. Okay, let's go to next question. Question number 16. Question number 16 says, use the information from this question to answer to number 17. Okay, of course. That is, we can consider later. But under question 16, they say, which of the following graph of the polynomial functions corresponds to an equation with zeros -6 multiplicity, zeros -6 multiplicity of 2, that is one condition. Other one is, and -1 multiplicity of 2. When you learn the concept of the polynomial function with multiplicity, these are the situations. Okay, I draw some examples. But remember, this is not the same graph, okay? These are the situation from the different graph. This is actually in the same axis I draw two graphs. These are look like a quadratic function. Quadratic function. Then the function touches the x-axis. That means x value is repeating. X value is repeating at these points. Then they say this has a multiplicity A. Multiplicity of 2. 0A. This function has 0A. Multiplicity of 2. If it is like that, we say multiplicity 2. If it is like that, we say multiplicity 1. This is multiplicity 2. This is multiplicity 1. If the graphs touch the x-axis like this, we say multiplicity is 3. Okay. Now in the given question they say there is a graph, zeros are -6 and -1. Then the multiplicity property of those points would be 2. Okay, out of that let's read this one. -6 and 2. In the graph A is like this. There are 2 points of graph A. These 0 values are 1 and -6. That means this is out. These 0 values are not -6 and 1. Graph B. Graph B is like this. This 0 value is -1. This zero value is -1. This zero value is 6. This is so 6 and -1. This is also out. Graph B. Yeah, that is graph B. Okay, this graph A, this graph B. Graph C. How is the graph C look like? Okay, I am drawing very approximate graph. Okay, this is not to scale. I want to just to show the shape only. In the graph C, they have indicated these intercepts as -6 and 0. -6 and -1. Yes, this has -6 and -1. -6 and -1. That means this is the acceptable graph. Okay, this is the right graph. That means answer is answer number C. Okay, as these informations are useful to the next question, I will draw this graph again. Okay, that is like this. Now I try to draw this more clearly. These are the x-intercepts, -6 and -1. Both of these points has multiplicity of 2. That means this graph has the -6 and -1 of multiplicity of 2. Okay, this is the right answer once again. Okay, now at the same time, let's discuss question number 17. That is actually a short answer question, no problem. Let's discuss this. Based on your multiple choice question 16, that means this question, based on this multiple choice question 16, write the equation of the function in standard form. Okay. Now we know the zeros. These are the zeros. SC equal negative 6, SC equal negative 1. This function has multiplicity of 2. By looking this, actually this oriented upward direction opens up. That means we can write the function like this. Fx equal x plus 6 squared is plus 1 squared. In order to have this multiplicity property 2, you can introduce 2 here. That is one thing. Again, when you set this to 0, you are getting these zeros again. That is just verification. This is the basic form of the function. Actually, this is valid only for the shape of the function. But in order to adjust the position, we have to add this constant. When you add this constant, we are able to figure out the most correct function. Otherwise, if you ignore this a value, if you put a value as 1, this function represents the shape only. In order to represent both shape and position, we can introduce a. Now our task is to find the value of a. That is easy. We know the point on the graph. Actually, we know the y-intercept. When SC equals 0, y equals 72. That means F0 is negative 72. Sorry, F0 is positive 72. Now let's input 0 here. 0. A times 6 squared, 1 squared. When you input 0 to both sides, we are getting a times, inside the bracket you remain with 6 squared. Here you remain with 1 squared. I wrote those information here, in the right side, okay? Once you substitute S equals 0, the right side will become like this. Equal to 72. Now let's simplify this. 6 squared, 36. 36 a is equal to 72. We are getting a is equal to 2. Now we can rewrite this function. Let's rewrite this function by putting the value of a. 2 times s plus 6 squared, s plus 1 squared. Okay, this is the answer. This is the equation of this function. That is done. The question says write the equation of the function in the standard form. Here's this answer. Okay, now in these last 3 videos, video number 1, video number 2 and video number 3, we have discussed actually all the aspects of possible question with the answer for polynomial function. Okay, that is done. That means for my whole series of videos, I have already covered from the beginning, transformations, then now we have discussed polynomials, logarithm functions and exponential, then trigonometry equation, trigonometry function. In my list, okay, also we have covered permutation and combinations. Under the permutation combination, there is a remaining part, binomial theorem. I will discuss about the binomial theorem in detail in my next videos. Thank you very much. See you again.